Last time we talked about volcanoes that catch scientists completely off guard. Mountains that sit quiet for decades, sometimes centuries, and then explode with almost no warning at all, turning an ordinary morning into a headline nobody saw coming. Today we are looking at something that feels almost like the opposite. There is a volcano in Hawaii that has been erupting again and again on something that looks a lot like a schedule, not a metaphor, a real trackable rhythm, coming from one of the most active volcanoes on the entire planet, and it is happening right now while you are watching this. Since December 23, 2024, Kilauea has been erupting in a way nobody alive has ever seen it do before. Inside a crater called Halema'uma'u, at the very summit of the volcano, lava keeps rising and falling from two separate vents, one on the north side and one on the south side, in what scientists call episodic fountaining. It is not one long, continuous eruption stretching across months. It is dozens of short, violent bursts of fire, one after another, spread out over more than a year and a half, each one its own event, with its own height, its own duration, its own personality almost, and then silence again until the next one arrives. Episode 50 happened on June 27, 2026. Lava shot up out of the ground for about 7 hours straight, glowing bright enough to be seen from miles away, before it stopped almost as abruptly as it started, the fountains dropping back down into the crater like a held breath finally released. And right now, as this story reaches you, scientists at the Hawaiian Volcano Observatory are watching the ground itself for the next one. Episode 51 is expected sometime around the middle of July, in a window that keeps narrowing and shifting by a day or two as the mountain breathes in and out beneath their instruments. By the time you are watching this, it may have already happened, or it might still be days away. That is exactly the strange part of this story. We are talking about a volcano active enough to have its next eruption estimated on a calendar, the same way you might check a forecast before deciding whether to plan a weekend outside. Think about what that actually feels like, if you lived close enough to see it. Not the panic of an emergency alert buzzing on your phone in the middle of the night with no context at all. Instead, something closer to knowing a storm is coming later this week, so you can plan around it, watch it build, maybe even go stand somewhere safe and simply witness it happen. There is also something quietly reassuring about a danger you can plan a trip around. People fly into Hawaii from all over the country, spend real money on a flight, a rental car, a hotel room, hoping the timing lines up just right so they can stand at a safe overlook after dark and watch the sky turn orange over that crater. Some get lucky and catch a fountain in full force. Others arrive during one of those quiet stretches, days or weeks of nothing but a faint glow, and leave a little disappointed, the way you might feel checking the sky for a meteor shower that never quite shows up. Either way, nobody is running for their lives. They are simply watching, from a safe distance, something the rest of the world still associates with pure disaster. Have you ever stood at the edge of Hawai'i Volcanoes National Park, or watched a real lava fountain glowing against the night sky, even second-hand, through a photograph or a live stream on your phone? Tell me in the comments, because I genuinely want to know how many of you have felt that kind of heat, or seen that kind of light, in person. If this kind of story pulls something out of you, hit like and follow along so you do not miss whatever number comes next in this ongoing count, because this mountain is still writing its own history in real time, one episode at a time. Here is the part that most people never stop to think about. A volcano does not just erupt out of nowhere, not this one anyway. It warns you first, if you know exactly where to look, and Kilauea has become almost fluent in the language of its own warnings. At the summit, scientists rely on an instrument called a tiltmeter. One of the main ones is named after Ukahuna, and what it measures is something almost invisible to the naked eye, the way the ground itself slowly rises and falls, in tiny fractions of a degree, as magma pushes up from below and then drains back down after each burst. When an episode ends, the ground deflates like air slowly leaving a tire overnight. Then, over the following days, it starts to inflate again, filling back up with pressure, patiently, the way a bathtub fills while you are doing something else in another room. Once that inflation climbs back to roughly the same level it was sitting at right before the last episode, the mountain is close to its breaking point again, and everyone watching those readings knows it. That single shift, from deflation back to inflation, combined with a steady, stubborn glow that scientists can see through night vision cameras pointed straight into the vents, is the signal they wait for. It tells them a window is coming, sometimes days before it actually opens, which gives them time to warn the park, close the right areas, and get ready. Sit with that for a second. Somewhere on this planet, there are people whose entire job is to watch a mountain breathe, hour after hour, night after night, and use that breathing to tell an entire community when it might be safe and when it might not be. Even the gas coming out of the summit follows its own pattern. Kilauea typically releases somewhere between 1,000 and 5,000 tons of sulfur dioxide a day, even while it sits paused between fountains, quietly venting the whole time nobody is watching flames. That number sounds enormous the first time you hear it, until you compare it to a volcano nobody was watching closely at all, the kind we talked about last time, where similar numbers of gas and pressure arrived with essentially zero warning and caught entire towns off guard. Here, on Kilauea, that exact same kind of number is just another Tuesday. It is part of the routine, folded quietly into everyday life on the Big Island. Meanwhile, the people who actually live near that summit are not thinking about tourism schedules at all. For them, this eruption has become part of ordinary life, in the same quiet way some of us check pollen counts before letting the kids play outside. On the days that gas drifts the wrong way, it turns into something called VOG, a kind of volcanic smog that can settle over towns and make breathing harder for anyone with asthma, anyone pregnant, anyone older whose lungs are already working a little harder than they used to. So there is a strange, layered feeling running underneath this whole story. Awe on one side from a safe distance, and on the other side, a small, familiar kind of worry. The same worry you might feel checking an air quality app before deciding whether to go for a walk, except here, it comes from an actual volcano, not a distant wildfire. And that, really, is the difference worth sitting with. On one side, you have Hawaii, where the Hawaiian Volcano Observatory has decades of continuous data on this exact volcano, on this exact crater, on these exact two vents, going back long before most of us were paying attention to volcanoes at all. That history is why they can call a window days in advance, why they can watch a tiltmeter and say with real confidence something is likely to happen around this date. It is also why Hawai'i Volcanoes National Park has kept the rim of that caldera closed to the public since late 2007, long before this current eruption even began, a decision made years in advance simply because the ground there has never been considered safe to stand on unsupervised. Decades of patient, unglamorous watching turned a wild, unpredictable force of nature into something scientists can genuinely plan around, the way you plan around a hurricane season instead of being ambushed by a single freak storm. On the other side, you have volcanoes like the one we covered last time, ones with almost no history of close continuous observation at all, no decades of tiltmeters, no long memory of past behavior to compare against. There, an eruption can begin, and nobody sees it coming until it is already happening, already changing lives, already on the news. The difference between those two volcanoes is not the size of the danger sitting underneath them. It is the size of what we actually know about it, and that single difference changes everything about how much fear a person living nearby has to carry around every single day. Now hold this number in your hand for a second, because it is the one that stays with people long after they stop watching stories like this one. Each of these eruptive episodes, these violent walls of lava shooting hundreds of feet straight into the night sky, lasts less than 12 hours, less time than a full day at work, commute included, less time than a long drive across a couple of states, and then, almost as suddenly as it started, it goes quiet again. Sometimes for just a few days, sometimes for more than 3 weeks of nothing but that patient orange glow at night. A volcano that has been actively, continuously erupting since December 2024, month after month, is at the very same time one of the most closely watched, best understood, most genuinely predictable volcanoes anywhere on the surface of this planet. Say that out loud, and it almost does not make sense. The words volcano erupting are supposed to mean chaos, sirens, evacuation, fear rippling through a community with no warning at all. Here, on this island, those same words mean scientists quietly checking a screen, the way you might check tomorrow's weather, before deciding what to wear. But do not let that calm you all the way down, because here is the question nobody can fully answer yet, and it is the one worth carrying with you after this ends. Every pause between episodes has followed a rhythm. A few days here, a couple of weeks there, over and over, Like a heartbeat, scientists have slowly learned to read and trust. But what happens on the day that pause stretches far past anything in the pattern we have seen so far? Does that mean the mountain is finally settling down, quietly running out of the pressure that has been feeding it since the very first episode back in December 2024? Or does it mean something is gathering underneath, patiently building toward a fountain bigger and longer than anything we have seen in this entire cycle? Nobody knows yet, not for certain, not even the people with the best instruments and the longest memory of this exact mountain. And that uncertainty, sitting quietly underneath all this order and prediction, is exactly what keeps every single tiltmeter reading worth watching. We will be right here for whatever number comes next.